The next thing I'm going to do is I'm going to jump into some of these software packages and show you how the audio interfaces are configured inside each DAW. All right, here we're in Reaper. I showed you really briefly before how Reaper works. What I'm going to show you is in the preferences how these audio devices are configured. So I'm going to hit Control P to get into the preferences. All right, so we're already set up for audio. Click on the device and it's going to look something like this when you first come into Reaper if you don't have your audio interface configured. So this is on Windows only. Generally, you're going to see something called Core Audio on a Mac. That's all you need. Set it to Core Audio. You should be able to access your audio interface right away. So in Windows, it's a little more complicated. So here I'll go through and explain what this says. So Wasapi is a really old format. Some of these other formats are really old as well. They're really for if you're using something like a built-in sound card, which I don't recommend at all. We're going to configure here. We're going to hit what's called ASIO. So what does ASIO mean? ASIO, Audio Stream Input Output. It's just a more modern format of audio device. And using ASIO on a Windows device is just going to give us much better results than using any of the other formats that are listed there. So I'm going to toggle over to ASIO, and immediately you're going to see ASIO driver because this driver is already installed. There's a few other ones on here that we're not going to talk about. So complete audio, ASIO driver, and then you're going to say enable inputs. So the first thing you're going to do is make sure that all of your inputs are enabled inside of Reaper. So that means that you can access all of those inputs from inside of Reaper. I don't know why you wouldn't use all of them, but that's how they have it set up. So we've got inputs 1, 2, 3, and 4. That's what I showed you before. The 2 on the front, the 2 on the back. Those are the 4 inputs. All right, so we're going to enable all of them. We're also going to enable the SPDIF digital inputs because, you know, I'm feeling sassy. So let's just do that. And then you've got the output range, same thing, 1 through 6. So complete audio 6, haha. That's why they mean complete audio 6. There's 6 inputs, 6 outputs. 2 of them are digital, hardly ever used, but there's still 6. You got through these, that's what you need. Once you get these set up, you're good to go. You never have to look at this portion of the preferences again. Something you're gonna have to do is go into this ASIO configuration. Some implementation on certain audio interfaces is better than others, but we'll see how Complete Audio 6 and Native Instruments does it here. So we're gonna click this. It's gonna come up with this little window, and the window says Complete Audio 6 and current sample rate, 44.1. Now, there's a lot of controversy about what sample rate to record at. I generally tend to stick with 44.1. It's the old format that CDs were, but CDs were 16-bit. So the difference between the way I configure things most of the time is I configure things as 24-bit when I record. I know some people like to work in higher sample rates and higher bit rates. That's fine. It's just going to create more of a load on your CPU. And since I stack a lot of plugins sometimes, I stack a lot of virtual instruments, that's not going to be really helpful for my process personally. If you're recording an orchestra or a band on a computer, I would say that you probably want to set your sample rate at a higher level just because you can. I don't think there's that much of a difference, honestly. I haven't really been able to tell that much of a difference for the things that I record personally. What you are going to look at, though, are your buffer settings. Buffer settings are extremely important when you're inside a DAW because it limits what's called latency. So when you press a key or have a microphone and you speak or sing into a microphone, that audio, and when it shows up in the computer and reflects back to you in headphones or speakers, that is latency. It's what's called a round trip of audio. So when you put things from the air around you, like say if it's your voice or you're singing into a microphone, it's going to go into the computer and it's going to convert from analog signal, which is what it is when you're holding the microphone in your hand, that electrical signal goes through the cable into the interface and it transforms it into something that the computer can understand. It transfers it into a digital format, which pipes through that USB cable into your computer and right out onto your screen in the DAW. So that's a complicated process that happens very instantaneously, almost. When we're talking about latency, the lower the latency, the better, because you want to hear what you're doing in real time or as close as possible. So anything really generally below 10 milliseconds is really good. It's far too less for your brain to understand. But anything over 10 milliseconds, once it starts getting to 15, 16 milliseconds, you're going to start to hear a delay from when you're pressing a key on a keyboard and when you're hearing the sound. And that just breaks the flow. It's not like playing a piano and hitting the keys. When you play an acoustic instrument, you hit the keys, you strum the strings, you immediately hear it. When you're using a computer, the latency will affect that experience and you're not going to want to use it. You're absolutely going to want your latency as low as possible. This is why you don't cheap out on audio interfaces, because you can't get that low of a latency if you just use the system audio and you're not using an audio interface. I'll rant over, but that's really an important point that has to be made about this process of integrating with your computer system as far as using it to make music. It absolutely has to be a fluid, real-time capability, or it's just not gonna work for what I'm trying to teach you guys. So what is buffer size? Buffer size is the amount of time it takes your computer to process incoming audio. So your buffer size can be super small. It'll take less time for the computer to process that audio that's coming in real time. A lower buffer size is going to mean faster input, which is going to mean less latency, which is what you want. However, it does add more weight onto your computer's processing ability. It's going to start to cause noticeable artifacts in your audio if there's not enough computing power to keep up for all the things that you have loaded up and all the inputs you have coming in. So there's got to be a compromise somewhere so that you have low latency but high audio quality. Generally, I set my audio to 128. As you can see, there's lots of different options here, from 8 samples all the way up to 2,048 samples. I would say somewhere between 128 and 512 is the sweet spot. Why is that? If you've got a lot of plugins loaded, you're gonna have to go to a higher sample rate just to get the audio to sound like it's not choking. So if you have too many things loaded and you have too low of a buffer size, you're gonna start to hear this like crackling, jittering kind of sound. That's definitely not what you want. You want everything to play back in real time so it's as fluid as possible. For input, as far as I'm concerned, 128 is great. It'll give you a nice fluid input as far as your keyboard control and as far as your output of your speakers or into your headphones, how quickly you'll be able to hear that. So that's pretty much a good compromise. If you look here, it says input latency, output latency latency, and then you'll see 2 millisecond formats here, 5.4 and 4.49. So the total between these two is a little over 10, right? It's like just barely on the edge of being usable, and it sounds fine when you're mostly not going to notice any delay. Once you start loading up lots of plugins though, if you're not recording actively into the interface into your computer, you don't actually need to have your buffer that low. So if it does start to crackle, if your computer starts to really kind of like stumble under the weight of how much processing you have going on, there's lots of ways to mitigate that. But the easiest, least time consuming thing that you can do is make your buffer size larger. So often if I have a bunch of plugins running in a session and everything starts to drag down, it starts to slow down, things don't become real time anymore, I'll just jump into these preferences real quick, switch it over to 512, and I'm good to go from here, from there on out. And then I just have to remember to come back in if I'm going to record, a keyboard part or record some vocals or something like that, or record a guitar. Then I have to come back in and make it a little more, lower the buffer size in order to get less latency. So you'll see when I change see how it says 5 and 4. So if I change this to 512, it's going to go up to 16 and 16. So that's 32, 33 milliseconds. That's going to be real noticeable if you're trying to play a keyboard and record into it. But if you're not doing that, it's great because you could just take the weight off of their CPU. It's like an instant thing where you're like, oh God, this session's really dragging down. I closed my browser. I closed all my stuff. I'm just grinding to a halt. This session is just, there's nowhere to go. This is like the easiest solution. Just crank it up to 512 samples and you're good to go. I would even go as far as to say, go up to 1024. That's when you're really getting up into latency. It's like 60 milliseconds of latency, but that's not a problem if you're just playing the things back. You just hit the play button and just wait for it to come up. You're just not going to be very rapid fire at that point. And then there's some other things that you can do to kind of mitigate that. But I'd say generally as a rule of thumb, leave it at 128, set it and forget it. Unless you're having problems with your scene or your project file slowing down significantly, you'll never have to go into this again. All right, so once you have those things set up, you hit OK. Up in the right-hand corner up here in Reaper, it will tell you the sample rate, 44.1 kilohertz, which, as I said before, is CD audio, I believe. And then 24-bit is the bit depth. Sometimes you can set it to 32. I don't think you really need it. If you're really insistent upon that, you're just going to take a little bit of a CPU hit. I generally just record at 44.1, 24 and call it a day. Sometimes when I work with video, just so I don't mix formats inside of like a video editing program, I'll go 48 kilohertz, and that's fine too. I don't go above 48 kilohertz almost ever. And I don't believe most people do unless you're making huge recording sessions with jazz instruments or an orchestra or something that really needs like that extra level of fidelity. All right, so that's Reaper. That's how all that's set up in Reaper from the audio interface settings. The next thing I'm going to do is show you how to do that same thing in Ableton.